Hello again. In this episode, we will configure lxc containers with DNS mask using static IP addressing. We'll then start and create a few containers, stop them, and see generally how they work. For this, we'll be using lxc, standing for Linux containers. Unlike Docker or LXD, lxc is very simplistic and is more designed for long-running containers, where you expect to be upgrading your operating system and maintaining them, unlike Docker, which is more tuned for deploying small applications where an upgrade essentially means tearing down your container and starting it again. If you haven't seen my previous movie, I suggest you start with that, although it's not required to follow this manual. I will start a virtual machine we created in the previous episode, demo 1. Right, now that this is started, we should be able to SSH into it. We got port 3333 forwarded to the demo container, demo virtual machine that is. I'm gonna jump straight to root here. And let's begin. So first of all, we'll install lxc. For that, you'd hope to be able to type in apt-get install lxc. Sadly, not on 1804. So we will edit apt sources.list. And lxc will be in the universe repository. We'll run apt-get update. And now we can apt-get install lxc and lxc templates. We'll need the templates, which are basically scripts that will deploy the containers for us. Without them, it would be rather difficult. Templates already do most of the operating system bootstrapping for you. Now, for those of you who are uninitiated in containers, they're basically like virtualization, but without actually virtualizing hardware. Essentially, it means bootstrapping a whole operating system into a single directory and then emulating or separating certain parts of the operating system for them. So, for example, the init that runs as process ID 1 on your operating system with a container started will think that this container is the whole system. The init process there will think it's process ID 1 and it will not see any processes that run outside the container. Likewise, the containers will also get their own network interface, so you can have multiple containers and multiple applications attaching to port 80 because each one of them will have their own interface, their own IP address. So this configuration finished. We got lxc running, but we don't have static IP assignments. So before we demo exactly what containers are so that you can see in real life, let's do some configuration. In etc default lxcnet, we will go ahead and uncomment a line which says lxc dhcp conf file etc lxc dnsmask.conf. We'll now proceed to edit that file. And in that file, we will add just one line, that line being DHCP hosts file and another file. Yes, seems a bit counterintuitive to do one file pointing to another, but that's essentially how it was created. Right, so now we will create this third file, and for now we will, let's add a container. We'll call it web proxy, and the IP assignment will be 10.0.3.10. We'll get to why we're doing that in a second. And at this stage, the only thing we have to do in order for all these configuration changes to take effect is restart lxcnet. Now that lxcnet is restarted, the only thing you ever have to do if you add another container to IP assignment in this file, this is the only file we have to edit now, container name, comma, IP address. Every time you edit it, you'll just have to issue a command to tell DNSMask to reread the configuration. This is done by typing in kill all with a signal sighub into DNSMask. Right, now that this is done, let's fire up our script, which was discussed in the previous video. Mount encrypted, this will mount our encrypted partitions. The extremely secure password of demo. Once we check mount, we'll see that our devmapper disk1 is also mounted to /data. Now we can create btrfs snapshot subvolumes even. So btrfs, before we do that, let's go to /data. This is completely empty. It's our partition that will contain all the data, including the lxc snapshots, lxc containers. We're doing this because that's a secure encrypted partition. In order to do that, we'll create a new subvolume. We'll call it lxc. btrfs subvolume create lxc. And now we have an lxc subvolume in the data directory, which is inside our encrypted disk mount. Now, in order to mount it, we will be mounting it in var lib lxc, which is where all the lxc containers normally live. In order to do that, we do btrfs mount the btrfs volume with an option of subvol or subvolume equals lxc, and then we pass the /def/mapper/disk1. This will allow us to mount disk1, but instead of mounting the whole disk, we will be mounting just the lxc subvolume. Let's see how that exactly works in real life. So that's done. Let's check mount. Looks the same as the data mount, except that this is the root subvolume and this is the lxc subvolume. Just to understand what they do, let's look at /data. We still got our lxc directory, which is also the subvol. btrfs subvol list /data. We can see that we have an lxc subvolume. Now, let's create a file, call it test1 in /data, and let's create a file in lxc directory, which, like I said, is a subvolume, called test2. So in data we see test1, lxc, and inside lxc we see test2. Now if we check this directory, which is the mounted directory, but with the lxc subvolume, you will see we only see test2. Therefore, the subvolume we created in /data called lxc can be directly mounted as a separate mount in a different directory. What does it give us? It allows us to create subvolumes on a single partition and mount them wherever we want to, without having to worry about disk space with different partitions and how much disk we give to each partition. It's all one partition, one single space, different mounts for different subvolumes. So we got the separation we wanted, we got the encryption we wanted, but we don't need to worry about multiple partitions. A bit of cleanup here. And now that we're ready, let's create some containers. So I'm going to edit DNS mask hosts. We're going to create two containers, one with web proxy and one we're going to call web server. I'm going to give it an IP 10.03.11. So to create these, you could easily just do lxc. lxc supports automatically using btrfs backing store like this, but then lxc snapshots and a lot of other tools don't work. Unfortunately, lxc does not have a proper bug-free implementation of btrfs, so we're going to do an extra manual command. Inside varlib lxc, we're going to create another subvolume. I'm going to call it web proxy. And we're going to create a web server subvolume. As you would expect, in varlib lxc, we see two directories now. It also means in /data /lxc, we can see those as well. /data is root, so we can see all the subvolumes. Now that we created subvolumes inside lxc, we can easily do lxc create -type download and name web proxy. Type download is a special type of template. It allows us to specify what container we want interactively while giving us a list, which is great. Just a few seconds for lxc create to set up a GPG keyring, and there we have it. We have a whole list of containers that we can use, including Oracle, OpenSUSE, Gentoo, Fedora, Debian, Alpine, Arch Linux, Plamo, and Sabayan. Oh, there's OpenSUSE. And we're going to stick with Ubuntu for this one. Again, what you choose is your call. We're going to go with Ubuntu, Bionic being the 1804. You can look up the code names on Ubuntu's website, which will tell you what version they are. And AMD 64 is the standard architecture for a server we probably want to use. And not long later, we have a new Bionic container. We can do lxcls. Standard lxcls will just show us the name, which is not what we want. We want to go fancy, so we'll do lxcls -f. We can see a bunch of states and the name. This is a container we can start, but before we do, we're going to create a web server one. Oops. So create a red start. Again, for simplicity, I'm going to choose Ubuntu, Bionic, AMD 64. and we get a second container. Now these containers, if you look at var lib lxc, they're still there. But if we look at web proxy now, directory, you'll see that there's config and rootfs. Config is a standard file that tells us how this container is configured, and this is auto pre-created for most use cases. It should be sufficient. For rootfs, you'll see that this is directory which contains a whole operating system bootstrap there. In our case, Ubuntu Bionic. So let's start the containers. lxc-start -n web proxy and web server. -fancy is long for -f. We can see that web proxy has got an IP address that we assigned to it, web server as well. So now we're going to edit our script because we like completion. After we mount /data, we also want to mount -o. We want it to work in degraded mode as well. And subvol will be lxc, which is exactly the way we mounted it just now manually, but with the degraded option. Into var lib lxc. So we have a script which we can launch instead of having to do anything manually now when the server reboots. At the same time, let's say we want to start containers on boot. We can just add it to our startup script. There we go. So I have a startup script in case the server reboots. Everything will be back to where it was. Now we can attach to our container we can do apt-get update. This is running purely in the container that we just bootstrapped without affecting the host operating system. No lxc tools here. We can run dist upgrade, get that container up to speed. Not that init ramfs tools matters in the container, considering it will never be used for actual kernel booting. Excuse me. We're going to do the same for web server. So lxc attach web server. If we want to execute a command from command line without actually going into the container, we can do this and execute our commands at the end, which will execute those in the container. Same as connecting to it and then executing them inside. So now that we're configured, we got two containers, we got their IP addresses. What we'll want to do is we'll want to install the web proxy and a web server in them, and we will want to configure them to port forward from the host operating system. So for the web proxy, we're going to use a very simple Go proxy application. It's simple but powerful, allows us to proxy connections that are coming to the proxy server, listening on ports 80 and 443, so HTTP, HTTPS, into further web servers. The cool addition of Go proxy is that it can do Let's Encrypt SSL certificates for you on the fly, as and when needed. Therefore, you don't need to ever install certbot or Let's Encrypt on your own and execute them. Go proxy will do it for you. Let's get this. So I'm going to just clone the Git repository. Actually, if I read this, there's a compiled version here. And this is GitLab. It can automatically run pipelines for you, including compiling. So I'm just going to download the compiled Go proxy. Seriously, there we go. If we click on the job and we click into browse, we can see the job artifacts. And it allows me to download the binary using wget nicely. So we're going to want to have the Linux artifact because we'll be running it under Linux. I'm just going to copy link location. Attach into our web proxy. I'm going to create a directory called /app where I'm going to put the application, the web proxy, and we just wget. Now, one thing you need to know about the web proxy, or sorry, about lxc containers is that they're very minimal. So anything you would expect there, you'll have to install yourself. Talking and typing at the same time doesn't come easy. Right, now that apt-get installed wget, let's try that again. And we've got go proxy. We're going to make it executable. And now back to the browser. Inside here, we have a config example. So let's create our own config. What do we want? Do we want to log requests? Definitely yes. Bind address port. Well, let's bind it to port 80 for HTTP. At this stage, we don't want TLS, so we're going to stick with TLS enabled false. And then you just set up a bunch of forwarding rules that you want to match. So in our case, let me grab the first rule. The job will be to proxy this connection. And for which domain? We don't really have a web server or web domain here. So the domain will be 127.0.0.1 because this is how VirtualBox forwards. Normally this is the domain that will match in the browser for which that rule will work. So for domain 127.0.0.1, for those of you who know Apache, this is the same thing as matching server name or server alias in Apache Web Server config. Path will be /, so we want to match the whole thing. I believe that's how we do it. Or by the looks of this, we don't even need a path. So job proxy, domain 127.0.0.1, target will be, and this is where we'll be forwarding connections to the other container, 10.03.11. This is the container we set up that we called web server, where we'll essentially put a web server there at some point. Now we're not forwarding to HTTPS, so we can ignore the certificate self-signed. So very simple configuration, log request true. We're going to bind into port 80. TLS enabled is false. And the proxy rule says that if somebody tries to access the server with a server name of 127.0.0.1, because we don't have a DNS server at the moment to play with, we're going to proxy connections to the other container, just like you would do with a standard, let's say, Nginx or Apache proxying configuration. So let's save this and let's run it. I got an error on line 1. Great. Should probably read the documentation at this point. Right, I stopped this video for a second because I didn't know what was going on. I thought there could be a bug in the software that I need to check what's happening, but no, the Go proxy I downloaded is a HTML file, which then points to the actual file. Let's get the actual file. The size is more like it. Let's check what we downloaded. Linux executable, so we're doing much better now. Make it executable and run it against the config. So far, so good. Now, at this stage, we probably want it to run in the background. And so, in order to enter in the background, we'll have to create some sort of systemd service configuration. So let's create it in etc systemd system init.d, what used to be so simple. And we're going to call it go proxy.service. Inside of which you need a few things to be defined. So we're going to specify unit. There we go. We're also learning how to create services in systemd. Description, and go proxy. Might as well do something useful in a description. You want to specify when you want it to run. We want it to run after network.target, meaning after network is initialized. We're going to be hooking to a network port, so definitely want to wait for a network to run. And now we configure our service. It's a very simple service. There's nothing magic that we need to do here. The service will run as root since we're hugging port 80. Working directory is the directory in which the service will run, and that'll be /app. And exec start is a command that we execute. So we execute /app/go proxy config.toml, exactly as we executed it. And we're going to tell systemd to restart the service if it gets aborted, which means on any sort of error other than actual quitting. And when should the service be installed? It should be installed when we're in the multi-user environment, which means we're in the correct run level. And that's pretty much it if it comes to the systemd. Now we will have to make the script executable. And enable it. So systemctl enable go proxy. And now we can do so cool things like service go proxy start and service go proxy status. Learn to type. And we got a web server. In case you're wondering if you need logs from systemd, it's journal.ctl -u and the service name go proxy. That gives us all the logs. You'll notice this error, failed to reset devices.list, operation not permitted. This is a systemd error, and that's because we're running in a container, so there's a lot of things not permitted inside the container. It's something we can completely ignore. So GoProxy is running, we can do netstat, or could if it was installed. So apt-get install nettools, I believe. look at what's listening, and we can see that Go proxy is there on port 80, so yay, success. Let's try to telnet to it. So telnet won't work here because it's not installed. Right, telnet, want to localhost port 80. We're going to issue a standard get command to get slash. All we get is bad request. If we check the journalctl logs, nothing there. It is a bad request. So get slash http slash 1.1 host 127.0.0.1. And this is a correct request for which we're getting an error. Let's go out of telnet and check the logs. So we can see that we try to connect to the server. We set up that we want to connect to 127.0.0.1 as the host name, and the target tried to forward our connection to 10.0.3.11 in a proxy fashion, just like we wanted. Unfortunately, it received a dial error because guess what? We don't have a web server running in our web server container. So connection refused, client gets bait gateway, exactly as it should be. So we got it running. Let's install something in the web server part. So lxc attach web server apt-get install. Probably the quickest way will be to install Apache 2. But that requires a lot of dependencies and a lot of packages. They want to do it. Maybe I do, maybe I don't. In my case, I'm going to go with something slightly simpler. There is yet another Go SWS, which is a simple web server. All it needs is a couple of options. We don't want authentication, so we won't be using them. And the directory it should be serving. So, hey, if that works, it should be very simple. I won't make the same mistake. This time I'll click Browse, Bin, Linux. Actually click on this, and that's where the binary is. Back here, we're going to install wget. And we're going to wget this, and maybe first let's make directory called /app again. I like /app, it's simple, and tells us where the application is. Container name tells us what kind of application it is. Judging by the file size, we got the correct thing, but let's check. Yep, it's an ELF, an executable Linux format, so a binary. Make it executable. So now we want to run it. Let's create a directory, maybe here. Call it www, instead of which we'll create some kind of file. Put some contents in it. Don't really feel like creating a website here. So we're just going to create two files. Okay, so we got two files in www, we got file.txt, we got index.html. Let's run it. We want SWS minus b:80, we want port 80. We want to print access log to see what we're doing, and we want it in /app/www. Wait, that worked. So at this stage we got a web server. Now we'll just need to configure it to execute exactly that command. copy it, using systemd so it runs in the background. Another systemd. Nope. We can just copy the one from the web proxy. So the cool thing about lxc containers is we can go to var_lib lxc, and there's web proxy, root file system from web proxy, and without attaching, we can just take files from it. So the file was in etc systemd system go proxy.service, and we're going to copy it into var_lib lxc web server rootfs. Exactly same location, but we're going to call it sws.service. Back to attaching into the web server, lxc attachment is on web server. We can now take this again because we'll need that command. Let me now edit the file var_lib inside the container, so no var_lib lxc. etc systemd system sws.service. SWS simple web server. Again, the whole configuration is the same, except here, where we run SWS instead. So that was simple. systemctl enable SWS service SWS start and service SWS status. We got the service running. Superb. So now theoretically, if we go back to our web proxy container and we do another telnet session, we're gonna get /http/1.1. Host is going to be 127.0.0.1, and we get the index.html served, which, as we said, says no. So let me try to now get /file.txt. Actually, let me try wget. Wget, we're going to print just the output and to screen http /127.0.0.1. No, perfect. /file.txt says help me. So we got a proxy which proxies connections to a completely different container. Brilliant. So what now? Now let's forward this port to our VirtualBox so we can access it from our host machine. So with the VM, devices, network settings, to click on advanced, port forwarding, and I'm going to forward port 8080 on my local machine to port 80 in the virtual machine. Back in the browser, we're forwarding port 8080, and that's not working. And for good reason. Now, we can access this from here. wget is installed, so let's try this on the host machine. It works, although it returns nothing. It will return bait gateway because, funnily enough, this is the wrong host. So we get 403 forbidden. If we try telnet, hey, we got telnet, which is great. Telnet 10.03.10, which is our proxy, port 80. Standard HTTP GET, but we tell it that the host name is what we specified in the proxy configuration, 127.0.0.1. This works perfectly well. And this is to be expected. Now, we'd like to be able to access it from the outside world. This is due to port assignments. So with VirtualBox, we're forwarding the host port 80 connections. Sorry, my host machine's 8080 to port 80 in this virtual machine. But the port 80 in this virtual machine goes nowhere because, let's be honest, the proxy is listening in a container with a different IP. As such, we'll need to configure iptables rules. Nothing really dramatic. All we need is to create a net rule, and because we're netting, pre-routing chain is the one in which port forwarding happens, if you wish to call it that way. We want to forward TCP. Now, if the destination is 10.0 to 15, I believe that's 10.0 to 15. Oops. Probably don't want that rule. Now, let me check. The IP address of our interface is actually, yes, 10.0 to 15. You can check with infconfig if you feel more comfortable with that. Main interface 10.0 to 15. So anything that comes to this host as destination 10.0 to 15 on port 80 should be denetted. So the destination net to destination 10.0.3.10 port 80. So again, it is a net rule in pre-routing where we're forwarding TCP port. If it's coming to our local machine, so this virtual machine, because that's its IP address on port 80, we will net the connection, so port forward the connection to the proxy container port 80. Simple rule. And it works. We're getting a no in the browser. Again, it's port 8080 here because that's how we set up forwarding in VirtualBox. We should be able to do file.txt, and that says help me because that's what we put there. So that works. We can now access the machine. Unfortunately, iptables rules will be lost on restart, and so we apt-get install iptables. What's the word? Persistent. An iptables persistent rule, let's say yes to saving rules, will allow the host to actually recreate those rules on startup. These rules are normally saved in etc iptables rules.v4 for IPv4, and we see all the rules dumped. We don't really need to take care of them or wonder about them. We see only the pre-routing rules that we created, which is literally the command we typed in. If we want to add another rule, say forwarding port 8000 also to port 80 in that machine, we'd do this. I'm not going to execute it right now. In order to save the rules again, the rules that we currently have. Actually, in order to look at the rules, we do -tnet, -l, -vn. That gives us nice list. In the pre-routing, 5 packets or 220 byte have been denetted. It matches, so they matched any source going into this machine on port 80. They've been forwarded to the container. Now, in order to save the rules, in case we add more rules, we just do iptables-save, and this actually prints the rules to stdout. So, which is quite good because we can do iptables-save and just forward this to etc iptables rules.v4. iptables rules, as they're set now, are saved. In case we play with iptables rules and really mess it up and would like to come back, all we have to do is we have to cut that file and pipe it to iptables-restore. So save saves the rules, restore restores them. On reboot, they'll be automatically restored anyways. And that pretty much completes our LXC demo. But we can do something more with btrfs. So let's try that. Let's go to varlib lxc. And we see that to containers, if we do btrfs subvol list slash dot current directory, we'll see that there's three. There's lxc, web proxy, and web server. So that's great. Let's go to our /data, which is the main point. This is the lxc subvolume that's also mounted under varlib lxc. So whatever's in this subvolume is present in varlib lxc because of the way we mounted it. Go here, we see the web proxy and web server. Now let's say I'm going to fiddle with web proxy configs, or actually run apt-get update, apt-get dist upgrade, and well, this is a Go application, so there's a very tiny chance I could break anything, but should it be something bigger, I could break it. As an example, I had someone recently run apt-get dist upgrade on Ubuntu 16.04 with a Zimbra mail server and confirm that they're sure they know what they're doing. Then they updated to 18.04, and Zimbra got automatically uninstalled because it's not supported on 18.04, so they destroyed their own mail server. So a good job if you're trying to actually do things like that. Let's create btrfs subvol create, and we'll call it lxc snapshots. We got another subvolume. And now, before I destroy my container or fiddle about with it, I'm going to snapshot it. In this case, we're on btrfs snapshot /data /lxc snapshot create /data /lxc web proxy. That's the one that will be our victim, into /data /lxc snapshots web proxy dot some kind of date. If I only knew what date was today. 16th of October. 1400 hours. That's my naming convention. Name it as you wish. And because demos would be too great if they just ran perfectly, so the actual comment is btrfs subvolume snapshot right, gather at the end. So not subvolume snapshot create, subvolume btrfs subvolume snapshot. Now this snapshot occupies initially 0 space. We can see in lxc we still got our web proxy and web server. We can see in lxc snapshots we get our snapshot. btrfs subvol list /data shows that we do have a snapshot here. Now, with this configuration, we can go into web proxy container. What am I going to do? I'm going to go Actually, I'm going to accidentally remove /app where our whole application is. Oops. I'm going to stop the service. I'm going to try to start it. And run a status, and it unfortunately says, I'm sorry, but the directory doesn't exist. You can't run web proxy. We're in a downtime right now. Great. I just accidentally broke web proxy container. Thankfully, if we go to lxc snapshots, you'll notice we have our web proxy snapshot, rootfs, and the /app is still there. Or should have been. Oh, that's silly me. App, not /app. It's /app when you're in the container, or app when you're outside. So yes, our app is still there. We have a couple of things we can do. We can either copy app into lxc web proxy rootfs. This, if I pressed enter, would do it. In this moment, once I do this, well, let's do it actually. Now we can attach back, start the container, start the service, status on the service, and it's working. Now, the moment I've deleted /app, disk space would not have been released. What will happen is BTRFS would mark that in the main subvolume, the web proxy subvolume, I have deleted those files, but they will still be there in the snapshot. This is the first point at which the snapshot is actually occupying some space. It's occupying the files that have been deleted in the main one. Now I've copied app back into the web proxy container or snapshot subvolume from this one, the snapshot being another subvolume. And what happened now is I'm occupying double the space of this directory, because there's the original directory that exists still in this subvolume that I've deleted. And then there's a new directory I created using cp in the web proxy subvolume that's also occupying space there that's not in the snapshot. So the snapshots don't occupy any space until you start making changes in the original subvolume, and then the only extra space that gets occupied is the changes themselves. This is rather cool for a number of reasons. We can delete snapshots very simply. btrfs subvol delete, subvolume deleted. Yes, it is as easy as that. BTRFS will take a bit of time to delete the subvolume in the background. It usually takes up to a minute for very large subvolumes. But let's create the snapshot. What was the command? btrfs subvol snapshot. This one, let's create it again. For the sake of it, I'm going to give it a different name. We get a new snapshot. And now let's say something really bad happened. I've run apt-get update and all hell broke loose because some dependency somewhere and web proxy is completely broken. Now I want to recover a full snapshot of my container to a previous state that I saved before I ran the upgrade. So in order to do that, first thing first, let's stop web proxy. As you notice, I could take a snapshot without actually stopping the container. It's a moment in time snapshot. It's literally how the disk was at that point when I ran it. And now we will recover the old subvolume, the old snapshot. Now it should be noted that the snapshot is just another subvolume with a whole subvolume tree. So web proxy makes the main subvolume, and the snapshot I created is the subvolume under it. but nothing stops us from doing this. Let's delete the web proxy subvolume. I've just deleted the container. And inside lxc snapshots, we'll find that we still have our web proxy snapshot. Perfect. Now the only thing we have to do is move it to the lxc part. Now I might not want to lose the snapshot just yet, so I'm going to do btrfs subvol snapshot. I'm going to snapshot my snapshot subvolume into /data/lxc/web proxy. So I'm creating a new snapshot subvolume from my current snapshot into data lxc web proxy. If we go back to data lxc, we got the web proxy, which is brilliant. Now, by default, it's not writable. Btrfs sets all snapshots as read-only, which is for good reason, for safety. The one command you have to remember is btrfs property set -ts web proxy read-only false. This sets the web proxy subvolume as read and writable. We can now do lxc start web proxy. We've just recovered a snapshot back into the container. Now, in order to verify that, let's lxc attach. Now let's do service web we called it go proxy status, and it is working. There's something on my local network that's really trying to access it from the point I restarted it. But for our own safety's sake, let's refresh this. Yes, it is working. So we recovered. Now I decided I don't need this snapshot anymore. Subvolume delete web proxy. As such, you can create a snapshot of your container, do whatever works must be done, break it if you need to, in all sorts of wonderful ways. And once you've broken it, if you need to recover, you can recover from the snapshot. If everything's working, you can make a new snapshot and then delete the old one if you wish to at any point. One other thing, it is possible to clone containers using snapshots, because we can. So let's say we create a container. I'm going to use web server for this one. That's our, so to speak, template container. So we got the web server one. I want to create another web server container, call it web2, and that's going to serve different web pages. So I'm going to do btrfs subvol snapshot web server into web2. Now, what has happened is I've created a snapshot inside /data/lxc. We got web server, web proxy, web2. Because web2 is visible in lxc directory, the container can see it as well. Yay! So I've just created another container from the web server container. What we need to do is we need to run the, property call to make it read and writable, and we can lxc start web2, except that one more thing, in etc lxc dns mask -host, we want to define web2 and give it some kind of static IP, say 10.03.12. And now I got, well, that's a bummer. We got 2 times 10.03.11. Now, how did that happen? Well, I'll tell you how. We go into web2 container, and as I said previously, there's config and rootfs. If we look at config, you'll notice that there's an actual path here. So if I search for web server, you'll notice that it's defined in config, so I'll probably want to edit that one too. And attempt number 2, lxc start, lxcls, and that's still 10.03.11. Let's stop this container for a second. And what you will also learn here is that I am blind to the obvious. Edit the config file again, and here's the name, web2. And because we want to be sane, let's create a new hardware address. It's to our own liking, so I'm gonna do go 24.08. Let's check hardware address in all the containers. And you'll notice that it always starts with 00163E, but the hardware address is otherwise made up. I changed this hardware address, so we should be good now as well. Start. And the IP has been assigned, 10.03.12. You'll notice that given long enough, DNSMask has reread the config file on its own, so we didn't have to do the sighub command. So now we get web2 container. Why would we want to do this if there's a perfectly valid lxc-create? Well, the reason for that is, as I said, containers don't actually occupy, snapshots of subvolumes don't actually occupy space. So if we look at the amount of space that web server occupies, that's 500 meg, and web2 occupies 500 meg. In reality, web server occupies 500 meg, and web2 occupies exactly 0. Nothing more than 0. It occupies the only thing that changed, and the only thing that we changed was the config file. So two containers, they're exactly the same inside, therefore, and one subvolume is made from the other one as a snapshot. Therefore, they're both sharing the same data on the hard disk. It's only when you change data in one of the containers, like in web2 we did, that those get detached in the file system. So we change config file. So web2 is literally consuming just 1.1 kilobytes, which is great because we can save loads of disk space when we're deploying a huge amount of containers. If we have just one template that we're using, we can then reuse that template by cloning it this way. Now I can go lxc attach into web2 and go to www, and I can change index.html to be more positive and say yes. Okay, this was in web2. Notice when I attach to web2, it still says web server, so editing the etc/hostname might help. And etc hosts. Now when I attach back to the container, it says web2. So etc hostname, etc hosts, and then I execute the hostname command, hostname web2. So now when I attach to it, I actually know which container I'm in. So we got web2, and we got the web server. Let's attach to web proxy let's go into app and let's edit the config file. So at the moment we got one domain, 127.0.0.1 pointing at 10.0. So now we're going to create another rule. We're going to, again, proxy. We're going to try something. I'm not sure this will work. Domain same, but path /web2. Or maybe call it /positive. It's a positive server. And we're going to set the target to HTTP target to http://10.03.12. And we don't have, well, we do have more domains actually, but we'll get to that. So job proxy, same thing, path /positive, and we're sending that to the other container. Let's restart Go proxy and let's wget. We'll try 127.0.0.1 first. Yes, that goes to this one. File.txt works as well. So we're hitting the container number 1, web server, and /positive should automatically send us to the other container. Which it does. Journal.ctl to get the logs. This isn't logging. So GoProx is definitely stopped. Yeah, there we go. It ends up in status. Well, I was hoping that would work. That would be quite cool. Let's edit the config. First things first, let me move that rule to the top. So with Go proxy, it reads and matches the rules in the order they're given. So it will almost always match this rule for 127.0.0.1. So if we want to separate for /positive, this new rule needs to be first. It will check domain matches, yep, /positive matches, yep. We're going to send it to this target. Or domain matches, yep, /positive, no, move to the next rule. And this one will then match. So correct order. Restart. And yes, we now go to 127.0.0.1 /positive, and that automatically gets proxied over to our second container. How awesome is that? And because we like to play with rules, we're going to copy this one, and long live localhost, we can match domain with 127.0.1.1 and also send it here to the web2. Restart. Now let's try wget 127.0.1.1. This one doesn't match positive in our rule, so just that. And it does indeed say yes. So our rules definitely work. If somebody goes into 127.0.0.1 /positive, it goes to web2 container. If somebody says goes to 127.0.0.1 but without /positive, it'll match this rule and it will go to our first web server container. And then if somebody goes to 127.0.1.1, it also goes to our happy Web2 positive container. So this is where Go proxy or a web proxy in front makes sense. You can, depending on the domain you visit or depending on the path, it can actually serve different locations. So if you're trying to serve your own website and a mail server from the same box, you can have mail server with a mail web UI in one container, a web server for your normal website in another container, and do something with the Go proxy. For example, if the domain is example.com or www.example.com, go to a web server container, and if the domain is mail.example.com, forward this to your mail container or mail UI container. That way you can serve multiples depending on domain. If you want to use just single domain, let's say example.com, you could serve example.com. So let's replace domain here with example.com. You could serve example.com, saying that's your domain, and forward it to your simple web server container that has a nice website for yourself. And for a path called /mail, for example.com, you could forward that to your mail container that serves your mail user interface. So if somebody visits example.com, they'll get your website. Example.com/mail will get proxied into the mail container, and you'll get your mail interface. So this is where having a proxy for the web service in front makes absolute sense, because you're filtering and redirecting depending on your needs. Everything else is containerized, so you can update, configure, and snapshot your container without affecting another one. So if you mess up your web server and you want to recover it, you don't have to recover your mail server container, which could contain your emails, because you'd lose emails from the last snapshot. Although there's ways around it, and we're going to discuss those ways in the future videos when we configure more containers with actual proper use. So upcoming in further videos will be containers which serve email, which serve Apache PHP, some databases, Byte9 DNS server, and a few more, and we'll be using proxy, this Go proxy, to actually distinguish between accessing the simple web server or Apache 2 or indeed the mail container. So stay tuned for that, and thank you very much for watching.